Hello there, everybody. I got another voice and slideshow video for you on Chapter 12. So for all my Math 8A students out there, we're going to continue talking about stats and probability, and today we're going to tackle section 12.7, which is about compound events. Compound events. What are compound events, and what do we need to do when we face up against them? So before we do that, just a little refresher. When we have probability, we have different things that have different outcomes, like rolling dice, flipping coins, picking cards out of a deck. Outcome is just the number of possible ways a scenario can turn out. If you make a list or a graphic of those possible outcomes, you have created a sample space, which is just a representation of all of the possible outcomes. Now, when we are drawing a card from a deck of cards, there are 52 different outcomes. But if we're drawing 2 cards from a deck of cards, there are more than 52 outcomes. There's actually a whole unique number of outcomes, and you can use the counting principle that we talked about earlier to help you figure that out. But what about probability when it comes to multiple events? Drawing not just one card, but drawing a card and then drawing another card. That's more than one event. And if you have multiple events, those events can be independent events or dependent events. And so this is what we call compound events. Independent events and dependent events work like this. Dependent events affect each other. Independent events do not affect each other. They're independent of each other. So an example of that would be when you flip a coin, and then you flip it again, and then you flip it again, or if you're flipping multiple coins, does what you flip the first time affect what you flip the second time? No, each event is its own separate independent event. Same for when you roll multiple dice or roll the same die multiple times. What you roll one time doesn't affect what you roll another time. They're each independent events. However, when you are drawing multiple cards from a deck, these events are dependent events. They affect each other. As an example, you have 52 outcomes. When you draw one card from a deck, there are the 52 possible outcomes. So the probability of drawing an ace of hearts is you have a 1 in 52 chance. That's not compound events, that's just one event. But if I asked you what is the probability of then drawing another card and having it be the King of Diamonds, the probability of drawing an Ace of Hearts and then the King of Diamonds is a little trickier. The probability of drawing an Ace of Hearts is 1 out of 52. But what's the probability of drawing the King of Diamonds? It's not 1 out of 52 because you already took one card out of the deck, and now you have a 1 in 51 chance of getting the King of Diamonds, not a 1 in 52 chance. So hopefully you can see why we call these dependent events, because what happens on the second event is affected by what happened in the first event. The basic idea with dependent events is that you have to adjust the second fraction because the number of possible outcomes was affected by what happened with the first event. And you could have a third event or a fourth event or a fifth event, and you would just have to keep on adjusting those sequential fractions. All right, here's an illustration. Let's say you had 9 students, 5 of them were girls and 4 of them were boys. Pink for the girls and blue for the boys. That's so reinforcing gender stereotypes, and I sincerely apologize for that. Sorry, but we'll just go with the graphics. All right, what if you are having a 3-on-3 basketball tournament and you needed to pick 3 players out of these 9 students? What's the probability of choosing 3 boys? What's the probability of getting boy, boy, boy instead of boy, boy, girl, or girl, girl, boy, or girl, girl, girl? What's the probability of getting boy, boy, boy? Well, you have 3 events here. 1 event for each selection of each player for your 3-on-3 team. When you pick your first player, what's the probability that it's a boy? Well, there were 4 boys out of 9 students. Pretty simple, pretty straightforward. But what's going to be the probability of getting a boy on the next pick? We have to really pay close attention to our fractions here. It's going to be 3 out of 8. You have a 3 in 8 chance of getting a boy on your next pick. Why is that? Because now there's not 9 students anymore. There are 8 students to choose from, and there are 3 boys out of those 8 students. So you've picked your second student, you get boy and boy. What's the probability of getting a boy on the third pick? Now you only have 7 students left and 2 of them are boys, so you now have a 2 in 7 chance of getting a boy on your third pick, and your overall probability of getting boy, boy, boy is going to happen when you multiply these 3 fractions together, and on top you're going to have to do 4 times 3 times 2. On the bottom you're going to have to do 9 times 8 times 7. Maybe you could do a little bit of reducing and cross-canceling, but eventually you should get 1 in 21. So you have a 1 in 21 chance of getting boy, boy, boy when you're picking a 3-on-3 basketball team from that group of 9 students. You might notice the tops go 4, 3, 2 descending, the bottoms go 9, 8, 7 descending. That's not a fluke or an accident. It kind of makes sense that it happens that way because of the way these dependent events affect each other. All right, so that's pretty much the lesson. When you have compound events, which are multiple events happening together, sometimes those events can be independent when they don't affect each other, and you just kind of do your fractions the way you would normally do, but sometimes they are dependent events and they do affect each other, and you've got to adjust those subsequent fractions. And the cool thing about this is you can use this kind of mathematical logic to help you win any kind of board game or card game that has dice or cards or any kind of probability in it, because you can figure out how likely or unlikely it is for something to happen. For instance, and I'll make this the last practice problem of the video, if you were playing Texas Hold'em poker with some friends and you really needed to get 2 queens, what's the probability of getting queen, queen if you drew 2 cards from a deck of cards? I'll leave that for you to try to figure out, although I will give you a little sample space action in case you need that to help you make your fractions. And that is pretty much it for this video. You're going to practice this by doing 15 problems from section 12.7 in your textbook. And I wish you the best of luck. I will see you later.